This is our sodium hydroxide system. This morning when we were doing our checks, we noticed that the sodium hydroxide actual dosage rate was a little bit higher than what our HMI was telling us. So today we're going to calibrate the sodium hydroxide injection pump so that it matches what we should be expecting out of it. So what I'm doing right now is I've isolated the day tank right here. And I'm actually drawing from this, what we call a calibration cylinder. So I'm going to draw it down till I get to a certain point, which will probably be right about there, 0. Then what I'm going to do is I'm going to crank this pump up to full blast for about a minute, see how far down, how much volume we use within that minute. Then I'm going to take that number, punch it into our HMI, and then from there we should get actual values of dosage rates. So like I said earlier, like this chemical likes to crystallize at a temperature below 15 degrees Celsius, and you can sort of see some of the crystallized chemicals starting to drop down there. Like when I was in high school doing chemistry, our chemistry teacher would teach us about the meniscus, and I thought, where in the heck am I ever going to use this? Apparently I'm using it every day. So if we look at the bottom of this bubble here, the meniscus is the bottom line, sort of like a lens. So that's basically where we get our volume from, not the top of the meniscus, but the bottom there. So once we started at the bottom of the meniscus was at 0, and once the pump stopped pumping full blast, it was at 35 milliliters. So that's the volume I'm going to take, and now I got to go do some math in my office to figure out the overall pumping capacity. But prior to that, I'm going to put everything back the way it normally was, shut this calibration cylinder down, open up the feed line from the day tank, and what I normally do is I'll crank this pump up one more time again, just because sometimes it gets airlocked in the transition, and there's a little air release valve in the back here. Well, I noticed some chemicals coming out of there, so I know it's not airlocked right now, and that's why I have that tank there at the bottom. So all good there. Let's go back to the lab. So we calculated 35 milliliters over 30 seconds. I'm just going to multiply that by 2, 70 milliliters a minute. Now I'm going to have to do the math so that I get the values in liters per hour. So you look here, calibrated chemical pump max flow rate in liters per hour is 4.35. So now I'm going to have to do some math to match up to get this 70 milliliters a minute in liters per hour. Now this is, we know there's 1,000 milliliters. Don't mind my writing. In 1 liter, so I'm basically just going to multiply that by 1,000, or this is actually what I normally show my my trainees when they're doing any sort of conversions. Let me go in here. Oh, right, 1 liter, 1,000 milliliters. So basically I'm going to cancel out my milliliters, 70 divided by 1,000. This is where I might lose some of you guys. 0.07 liters per minute. Those are the 2 units we're left. Now we know there's 60 minutes in every hour. So in this case we're going to multiply it by 60 minutes per hour. That way our minute units are going to cancel. We have this at the top, that's at the bottom. So 0.07 times 60 equals 4.2 liters per hour. So yeah, there we go, 4.2 liters per hour. The calibrated chemical pump max flow here is 4.35. So we're just going to punch that value into there. And there you go, the the chemical injection pump has been calibrated. Last but not least, our maintenance management plan. And I'm going to record that we actually calibrated that injection pump. And that would be for pump 1903, because that's the pump that's running right now. There we are, pump 1903. Today is August 9th.